In these problems, I'm looking for the greatest common factor. That means what's the largest number in variables that can multiply to get both of these. Okay, so I'm going to do it as two separate pieces. First, I'm going to deal with the numbers. So I'm going to deal with this 6 and this 4. So what's the greatest common factor of 6 and 4? Well, you can think of what all the factors are of each of these numbers, right? I can say, okay, well, 1 times 6 is 6, and 2 times 3 is 6. So here are the factors of 6. And I can say, okay, well, 1 times 4 is 4, and 2 times 2 is 4. So here are all the factors. And I can see, once I have all the factors listed, that the greatest one that they share, the largest one that they share is 2. Okay. Now, you can do this listing, but some of you might find that, if you just look at the two numbers and you think, oh, well, those are both, they're both even numbers. They're both divisible by 2. And then you always have to ask yourself, well, is there a bigger number that they can both be divided by? And the answer is no, right? Like for 4, yeah, there's a bigger number 4, but you can't multiply 4 to get 6. Okay, so next I'm going to deal with the variables. So over here I have two m's, right? That's m squared, and this is m to the 3rd power. And so the question is, what's the smallest number basically that I can multiply to get both of them? And what I notice is that there's an m here and an m here, right? And there's another m here and another m here. So they share these two m's, and that is the greatest common factor. Oops. That is the greatest common factor, these two m's, so it's m squared. And the reason is, m squared I can multiply by 1 and get m squared, or m squared I can multiply by m and get m to the 3rd, right? So it's the same idea as the number. I'm looking for what are these factors that they have in common. Okay, let's look at another one. So here I have, I'm looking for the greatest common factor, and I have this polynomial, right? So I have some plus and some minus. But the thing is I'm still going to actually kind of just do the same process, right? I'm still looking at these 3. So I'm going to start with the numbers, right? So I'm going to start with, I have my numbers 18 and 4 and 2. Now I could list all the factors of 18, right? I could do 1 and 18 and 2 and 9 and 3 and 6, but I actually don't need to. What I need to do is just look at this smallest number and say, you know what are the factors of this number? And it's actually just 1 and 2. So because I'm looking for the greatest factor, I'm just going to kind of start at the bottom, start at the largest one, the 2, and say, okay, well, is 2 a factor of 4? Oh, yeah, it is. Is 2 a factor of 18? Yeah, right? 2 times 2 is 4, and 2 times 9 is 18. So therefore, 2 is the greatest common factor. It can't be any bigger because 2 is the largest factor of 2. So I'm going to put 2. Okay, and now let me look at the variables, and I go to look, and I say, okay, well, in this first one I have, 4 v's, and then in the second one I have 2 v's, and then the last one I don't have anything. I have nothing. There's nothing that's no variables in this third one for me to say, oh, they have that in common, and so I'm done. It's just 2. If there was a v right here, then it would be 2v, but there's not a v, so that v is in common for this first one, right, and for the second one, but because it's not shared in the third one, it's not part of my greatest common factor. So the greatest common factor here is just 2. All right, and then let's look at this last example, and then you'll have a chance to try. So numbers first, I take a look and I see, okay, this number, what's this number? Oh, this is a 1. That's a 1 right there. So my numbers are 1, 18, 9, and 8. And here's the deal. If you have a 1 in there, then that's the greatest common factor, because 1 only has one factor. So I'm looking for the factors that they all share. 1 only has the one factor, so it's 1. You can write 1. If you have a variable with 1, you don't even have to write it. But I'm going to write 1. And now let's look at my variables. And so here I have 2 t's, and then here I have 3 t's, and with the 9 I have another 3 t's, and with the 8 I have 4 t's. So what do I observe? I observe that I can see a t in each and another t in each, and that I have 2 t's in common, and I can't highlight any more t's because I'm all out of t's here. But I did notice that each of them had 2 t's, and so they share that, and so I could write 1 t squared, or you could just write t squared, right? Those two things are the same. All right, so now it's going to be your turn to try.